Hi, everybody. My name is Michael Libby. I'm the founder and CEO of Worldbuildr, and I'm here to talk to you today about virtual production for live experiences and attractions, and specifically how real-time game engines like Unity are rewriting the rules for location-based entertainment. In today's presentation, I'll give you a brief overview of who I am and my background. Then we'll talk a little bit about the experience economy and what that is and what it means. We'll talk about the problem facing the industry, and we'll briefly cover the history of pre-visualization for attractions and experiences, drawing a line all the way back to the creation of Disneyland, bringing it up to modern day. And then we will talk about what Worldbuildr is doing, my company, and how we're using Unity in some creative ways to troubleshoot some of these problems. Then we'll talk about Unity Reflect, which is an exciting new toolkit from Unity, and how we're integrating it with the Worldbuildr software. We'll talk about some potential applications for Unity and game engines in general to transform the experience economy. And then briefly we'll cover what's next and take a brief look into the future, both in terms of the experiences themselves and Worldbuildr's roadmap, where we're going and where we hope to take the software. So we'll start with a brief overview of who I am. Well, I'm someone who's always been very interested in theme parks, to the point where I worked part-time at Disneyland on the Jungle Cruise ride and several other attractions back when I was in college. I then graduated and worked for about 5 years as a creative director and writer for various entertainment design firms. And then I went and got a master's degree from USC's School of Cinematic Arts, their Interactive Media and Games division. And this is where I was first exposed to Unity and, to formal game design theory and VR. And it really transformed both my life and my career. My thesis project is basically where Worldbuildr started. And everything that has come since has been an evolution of the work I did during that program. A couple of highlights in terms of projects that I've worked on include the Purge Breakout traveling escape room from I think 2013, as well as Warner Brothers World Abu Dhabi, the world's largest indoor theme park, which opened in 2018, about 2 years ago. And my focus there was on the flagship attraction, Batman Night Flight, which we'll talk about a little later in this presentation. We should talk about what the experience economy is, because it goes far beyond theme parks. This is simply the idea that, as I'm sure many of you have heard, kids these days, they don't want things anymore. They want experiences. And there's a whole economy surrounding this that includes museums and brand experiences, themed retail, casinos, live events, theater, and of course, more recently, virtual experiences that take place within video game worlds themselves. For all of these things, it's very difficult to explain what you're trying to build before you build it. When you're trying to create a new type of experience that has never been done before, that includes many different multimedia elements, and immersive, wayfinding and navigation and things like that. It's very difficult to abstractly explain to somebody, particularly to a non-creative person, what it is that you're trying to do. And, this has been a problem, or a challenge rather, for, over 60 years, dating back to really what was sort of the dawn of this industry, the opening of Disneyland in 1955. Now, there, of course, have been other location-based experiences prior to Disneyland, but Disneyland is the one that really formalized the medium and kind of kicked off this new wave of thinking about going to a destination and having an immersive experience. And Walt Disney had to convince investors that he wasn't crazy and that this was the right thing to do, and to explain the concept of Disneyland verbally to somebody before something like Disneyland existed, was quite the challenge. So quite famously, he sequestered himself with one of his best artists named Herb Ryman, and over the course of a weekend, he verbally explained, "This is what I have in my head, and I want you to draw it." And Herb Ryman came up with this illustration, which is actually remarkably similar to the final park that was built. But this piece of art was incredibly key in presenting the concept to potential investors and really communicating what it is that they're trying to build. So again, this has been a continuing challenge, and there have been various ways of pre-visualizing location-based entertainment experiences over the course of the years. Here's another shot of Walt Disney using models and miniatures for the Matterhorn Mountain. This was probably a photo from around 1958. And models and miniatures are a very effective way of showing people exactly what the plan is, what you're going to build, how it's going to look, how it's going to be painted, how it's going to be lit, what the scale is going to be. And this was a tool and technique that Disney used to great success for many years. You'll also see in the center there a photo of Ron Toomer from Arrow Dynamics, taken about in 1991. Arrow is a roller coaster company, and in order to start experimenting and visualizing roller coasters that they were going to build, Ron Toomer would, I kid you not, take a coat hanger and bend it into the shape of a loop and into the shape of the track that he envisioned for that particular roller coaster layout. Quite crude by today's standards, but it was effective in starting to communicate exactly what that roller coaster track was going to look like and how it was going to hug the landscape of the site that they were going to be building on. And recent developments, including game engines, have allowed for some more sophisticated pre-visualization. Disney now has this thing called the Dish, which is a digital immersive showroom, where a user can stand or sit in the middle of this projected volume and walk around and move through an environment, and again really get a good idea of sight lines and scale, cinematic reveals as they walk into a new area, timing of various show elements. So over time, these pre-visualization techniques have gotten more sophisticated, but they've actually struggled to keep up with the advances in sophistication of the attractions themselves. Modern attractions and experiences are just these incredible amalgamations of multimedia and architecture and engineering and theatrical storytelling disciplines, and they all need to work together seamlessly to create an immersive experience where the guest can actually suspend their disbelief. And this is an increasing challenge. And according to a recent report, over 20% of construction projects run over schedule, and over 80% of construction projects run over budget. And this amounts annually to a $450 billion a year problem. And that's just for traditional construction. When it comes to location-based entertainment, these things are even more complicated. And the real problem is that, there are many different technologies in these attractions and experiences and many different moving parts. It's a very collaborative medium where you have writers, illustrators, architects, sound designers, engineers, media producers, audiovisual integrators. They're all working on these different aspects of these projects, and they all need to come together on site by opening day. And this is a real challenge. During the production process, a lot of these different companies are vendors, and they work in isolation, separately from each other. They're doing their respective scopes. They're doing a great job. But then when everybody descends on site into the field where they're actually building the thing, the construction phase often reveals some very expensive mistakes, where these things don't come together as planned, and concrete has already been poured, and all of a sudden you're faced with some very expensive change orders. Now, there have been advances in BIM modeling, that's building infrastructure management, which does mitigate the risk for the construction of traditional buildings, but not location-based entertainment. There is really no tool for that, because location-based entertainment is a subsect of construction, but it's much more complicated because you have a lot more moving parts. And specifically, for most of these location-based experiences, what you're actually experiencing is a timeline of events, a series of triggered events that have been pre-programmed to happen at various different times. So an example of this would be the Batman Night Flight attraction that I mentioned earlier, which opened at Warner Brothers World Abu Dhabi in 2018 and is the flagship attraction there. And here's a photo of that ride. And as you can see here, this is a very complex attraction with a lot of different elements here. You're seeing some practical show elements. You're seeing, of course, theatrical lighting. You're seeing media screens. And you're also seeing media domes. These are immersive media domes. And on the left over there is the ride vehicle where 4 people will sit basically on the end of this mechanical robotic arm. And that arm will move to simulate flight. And that arm itself is on a track. It's moving throughout the facility. It's moving into these media domes where the vehicle will move and create some simulation moments. But then it also moves out of these domes and into some of these practical sets where show action effects are triggered, lighting cues happen, media is played back. And again, I can't stress this enough. All of these different things are being done by different vendors, different people, and often in isolation. And just to show you an example of some of the challenges here, take a look at this. This is a section view of one of these media screens. And you can see there's the tall truss on the left that's supporting the media screen. You're seeing that curved screen in the middle of the truss. And in the upper right is the projector that is going to be projecting the actual content onto that screen. Now here's the challenge. As that ride vehicle is moving around and that robotic arm is moving, it can extend, and you have to be really careful that if the arm breaks that plane and goes into the throw of the projector, it will cast a shadow on the screen and the illusion will be destroyed. So this is really a dance. Where do you place the projector? Where do you place the screen? What is the angle of the projector throw? And how do you move the vehicle so that it doesn't get in the way of that projector and cast a shadow? And all of these things are fraught with hazard, and many different things can go wrong. And so that's where the Worldbuildr software comes in. And we did this work on behalf of a design firm called Thinkwell, which did all of the creative design and development for Warner Brothers World. And we used our Worldbuildr software to pre-visualize a lot of these things. These are robotic arms that are being animated, but we need to figure out what are the sight lines from the individual seats, and how does the vehicle move, and what gets triggered when, and are we clear of the projector throw, and all of these things. So we were on site in Abu Dhabi, and we were iterating on this constantly, where we were on a tight schedule, and we did not have a ton of time to sit on the ride vehicle and experience and witness these things and then make changes. We did a lot of these things virtually, where we would figure out the timing and that balancing act of all of the elements. And then ultimately we would alter the programming of the ride vehicle motion and calculate what needs to be triggered when, so that the illusion is seamless. And so you can see here a side by side of some of the simulation work that we did with the final vehicle movement. And everything was done very carefully. It was a balancing act so that the vehicle moves away from a screen before the media on that screen ends. so that, again, everything works seamlessly and all of the elements are integrated together nicely. So this was an invaluable process for getting to the finish line on this attraction at Warner Brothers World and opening it with a successfully integrated product where everything was timed and being triggered at the right moments. So what we really learned from that process is that, something that many of you might be increasingly aware of, that Unity and real-time engines in general have increasing potential applications that go far beyond games. And what we've chosen to do with Worldbuildr is create a pre-visualization tool specifically for the show control programming of these location-based experiences. Now, this is software that is a professional caliber software. It is meant to be used for professional installations and experiences. But we've also created something. We've used Unity to create an interface that is easy to learn and use by people who don't know how to program. So the idea is that we have an interface that's as intuitive and easy to use as other content creation tools like Minecraft or Roblox, where you don't need to know how to code at all, but you can use our software on a professional level to program and integrate these things long before the construction process starts. So let's take a quick look here at the Worldbuildr software and how it works. So the first thing that you'll notice is that we are currently not in the Unity editor. One of the big differences about Worldbuildr is that it is published software created with Unity. So you do not need to have Unity installed on your computer to run the Worldbuildr software. It's self-contained software. So I'm going to double-click and launch the software. And as I mentioned before, the Worldbuildr software is designed for any type of location-based experience. But today we're going to be focusing again on dark rides. So once the application is launched, you're faced with this configuration screen. And this is where we set the starting values for our simulation. And this number right over here, THRC, that stands for Theoretical Hourly Ride Capacity. And this is the most important number for any attraction. This is the number of guests that can move through this attraction every hour. And this is a critical number. This is how many decisions are made based on this number. And let me show you a little bit about how the screen can be configured. Your dispatch interval here is the amount of time between dispatches of vehicles, just like it sounds. So right now it's set to 25 seconds. Every 25 seconds, we're going to dispatch a new fleet of vehicles. And you'll notice, if we increase the dispatch interval, that means there's more time passing between dispatches, which makes the THRC go down. And the advantage of having more time between dispatches is that the vehicle has less of a chance of seeing the vehicle in front of it or behind it. The higher the dispatch interval, the more spread out the vehicles are. But again, your throughput goes down. Let's keep it at 26 here. Vehicles per dispatch. This is the number of vehicles dispatched in a fleet. So every dispatch interval, when that interval occurs, we're going to dispatch a new fleet of vehicles. And in this case, we're going to dispatch 2 vehicles. And the number of seats per vehicle, again, you can see if we change that, it's also going to automatically update the THRC. The more seats per vehicle, the higher the THRC. And for our vehicle type, we're going to stick with ETF. ETF is a Dutch company that manufactures some great ride vehicles, and they're some of my favorites. And we're going to set our starting camera mode here. We'll start with our sweep camera, which is sort of our cinematic overhead camera. And we're going to toggle some options here. Let's leave it as is. We'll start with the facility turned on, the show doors turned on, the ride paths turned off, and the vehicle envelopes turned off. And for our crowd flow, this percentage is relative to our throughput. So we're saying that our sidewalk traffic essentially is going to be equal to our throughput. And our demand is the percentage of that sidewalk traffic that is interested in going on this attraction. So let's keep it at so let's set that to around 70%. And then we're going to click Start. And the simulation is going to begin. Okay, so now we've started our simulation with all of those starting values. We're using the ETF vehicle. We're launching 2 vehicles every dispatch at the dispatch interval that we selected. And you can see, we have our THRC here, our dispatch interval, our seats per vehicle. And great, so all of those settings have imported when we started the simulation. So what I'm going to do now, I'm going to change the camera to our orthographic camera. And this is where we can get a really clear view of what's going on in the scene. I'm going to go into my visibility options here and turn on my ride paths. And what we're going to do here is look for right there, that bright orangish reddish disc under that vehicle. That is our hero vehicle, or our currently selected vehicle. So that means if we were to go into the vehicle POV, we would be able to actually see what that vehicle is seeing here. But we can go to the next vehicle or the previous vehicle instantaneously. And let's go back to our overhead camera. Let's do perspective camera this time. So again, we are launching 2 vehicles at once. Our selected vehicle is right there, but if we move to the next vehicle, you'll note that it is on the red path. So every other vehicle is on the red path and every other vehicle is on the blue path. That is again because we are launching 2 vehicles at once. So in an area like this one, the front vehicle is going to go to the right, and then the rear vehicle is going to go to the left here. You can see how those paths are different. So now, let's change our camera to our player camera. So this is our first-person camera here. And we're going to move in, and you can see this is where we would queue up. And our queue would take us to the load station. Let's get a nice overhead view here. Great. And I'm going to go ahead and turn on my work lights just so we can see things a little bit more clearly for just a moment. Okay, so let's move our player camera, and I'm going to show you something pretty cool here. All right, so what we're seeing here, this is a very common effect used in theme park rides. It's called moving eye point media. So you can see that vehicle, when it goes over a trigger, it is triggering the media here on this projection screen. But the media here is one continuous uninterrupted shot, and the perspective of the media has to match the movement of the vehicle in order for the illusion to work. So the vehicle goes by, and you can see that perspective in the media is changing to match the movement of the vehicle and to create the illusion that there's a depth in this scene. But what if we change the ride path? What if all of a sudden there's a creative change or something unexpected? Now let's go back to our overhead camera here. And if you see that red dot over there, that is actually our cursor. And as I move the cursor like this, you can see it is highlighting these trigger points. And when these vehicles go over the trigger points, it triggers the various things that happen on the attraction. So I'm going to reveal my trigger cues here. So again, when this vehicle goes over this cue, it's going to rotate the vehicle 90 degrees over 5 seconds, and it's going to trigger this door to open. But then if we move to the next point, you can see there are triggers on or various different types of triggers on different points on the path. And all of these can be edited right here in the inspector. So this is triggering a light to go on, but we can select a different light in the scene. And we can change the duration that the light is activated. We can change the fade in, fade out time, and we can change the delay. So if we make that change, it will then take effect for the next vehicle that goes over the path. So we can make a change here. For example, have this lighting cue trigger a different light. Then we can move into our vehicle POV mode, and we can see that change happen in real time. So let's go back to our perspective camera here. So now I'm going to show you something really cool. Okay, so let's scrub our cursor over here to where we left our player camera. Now let's switch back to the player camera. Great. So there is our cursor, and there are the trigger points. So let's say the ride vehicle path changes. There's a creative change, and they want the path of the ride vehicle to be different. Well, now the user, the creative person, who does not need to know how to code whatsoever, can go in and use this Worldbuilder interface, and we can pick a point, and we can just start moving that point on the path in real time. And we're actually going to be bending the track here. So we've just made some changes, and you can see the next vehicle that comes through the scene is going to automatically take that new path, and the moving eye point media perspective is going to auto-correct to match this new ride profile that we've created, and the length of the scene auto-corrects to stay the same. So by integrating all of these things together during pre-visualization, we can avoid really expensive mistakes later. Now you can see that next vehicle that went through did not take that new path. Again, we've only changed it for every other vehicle. So that is where vehicle 1 is going to go. It's going to take, that's vehicle 2, right there. And then the next vehicle is going to take this other path. So now let's turn our work lights back off. Okay, so let's have some fun with this. Let's find a lighting cue here. Activate our panels. And we're scrubbing over the ride path. Okay, right here. How about this? So when the vehicle goes over this cue, it's going to activate this spotlight here on Tiki Rick. So what we're going to do here is change the duration and the delay. And let's add a little bit more fade out time. So then the next time a vehicle goes over here, those changes are going to automatically take place. And so we can see immediately what the change in the show control is. All right. Now let's go back to our overhead camera one more time. Turn off our cues and turn our work lights back on. Now let's talk about guests for a moment and THRC. So remember, we set those starting values of guest flow at 100% and guest demand at 70%. So that means the flow of sidewalk traffic is going to equal the throughput that we've currently set, and the demand, meaning the percentage of guests that enter the attraction, is going to be at 70%. So now we click on Spawn Guests. And you can see our guests are starting to spawn here. And let's go to our player camera here. And we can zoom out a little bit. And you can see that we're spawning guests at that THRC, and about 30% of them are just not interested. Okay, so I'm going to fast forward a little bit here. And now let us move here to our load station. And this is where our guests are queuing up. So you can see here our guests are going through the queue. And these dots here represent an entire fleet's worth of guests. So remember, we have 2 vehicles launching at once. Each vehicle has 4 seats on it. Therefore, there are 8 positions here. And all of these things are linked to each other. So if we change the dispatch interval, we saw the THRC go down. And what's going to happen is if the demand and flow values are unchanged, it's going to auto-adjust, and we're going to see the way that it affects the queue. So all of these things are connected to each other. The vehicle path, the perspective of the moving eye point media, the triggers for lighting and audio, and with this interface, we're now able to program everything in advance, see how it all works together. So we'll continue to dial this in, and once we get it to a place where we think it's performing exactly as we want it to, then we can move on to having the software actually control the final attraction once it's built, because we've already done the hard work in advance. So that is just a taste of the Worldbuildr software as it applies to a dark ride. For now, this might be a great tool for a drive-through experience during the COVID era, but once things get back to normal, we'll be able to use this for attractions of all types and get guests out of their houses and back to physical, location-based entertainment experiences. So as you can see, Worldbuildr exists right in that sweet spot between architecture and entertainment, where you see a lot of advancements happening in terms of pre-visualization and pre-production using real-time engines for movies and TV, such as a lot of the advancements that have been created and innovated for The Mandalorian and volumetric LED panels. And on the other extreme side of things, there have been a lot of advances in using real-time engines for architecture, engineering, and construction. But Worldbuildr is unique because we are focusing on location-based entertainment experiences, which really are a hybrid of those two disciplines. It's a very exciting time for us as everything is becoming more experiential. And when the world gets back to normal after COVID, there's going to be all this pent-up demand to go out and have these experiences. But we do need to build them smarter and faster and cheaper and with less risk. And one of the more exciting things that we've been developing very recently is integrating Unity's new Reflect platform, which is a major step forward for pre-visualization of architecture, engineering, and construction projects. Reflect has some really cool functionality built in. For example, cloud synchronization of assets, which makes sure that everybody's on the same page at the same time. Designers, investors, construction workers. With Reflect, for example, you can have a construction worker on site on the other side of the world, holding up a tablet and visualizing what that 3D model of the architecture is going to look like at scale on site, and then communicate back to that 3D modeler who might be using a program like SketchUp, back on the other side of the world and say, hey, can you make this quick change? Then that SketchUp modeler will update his SketchUp model, click save. Then that construction worker will just tap the refresh button and instantly see the change due to this cloud synchronization. So functionality like this is built into Unity Reflect. And we're very excited to be using these new tools and building off of this Reflect platform to add these new timeline-based entertainment triggering functionalities and pre-programming abilities. So this is really only scratching the surface. We've talked about more traditional location-based entertainment, things that you've already seen. But there's a lot to come, and things are changing. Modern audiences want interactivity. They want to engage with a story, and they want to affect that story's outcome. There have been a few instances of attractions that utilize real-time engines. You have your Turtle Talk with Crush, which opened in 2004, which features a real-time puppeted character that is a rigged 3D character that is being controlled by an operator backstage, but really creates the illusion that people, and specifically these kids sitting up front, are interacting and talking with an actual character on screen. 4 years later, Toy Story Mania opened up, and this was also a milestone attraction because it is running on a real-time engine, and guests wear stereoscopic glasses, and they are firing these cannons at targets and getting points. So it really is like a shooting gallery, but the whole thing is real-time. None of the media is pre-rendered. And the scoring mechanics and the aiming and firing and collision, that is all being done in real time using a game engine. And then most recently, probably the biggest milestone was last year, Millennium Falcon Smuggler's Run opened at Star Wars Galaxy's Edge, which is a new immersive land at both Disneyland and Walt Disney World in Florida. And this is an incredible attraction from a technological standpoint, where you are actually piloting the Millennium Falcon, and several guests are controlling the up, down, left, right movement of the Falcon and actually flying it, while other guests are shooting lasers at TIE fighters and controlling the engineering. But this is all real-time media. And, this is really the first time something has been done at this resolution, this level of graphics. And none of this is pre-rendered. It is all real-time generated imagery. And it's all procedural based on the guest's input. Looking a little bit forward into the future, there's no reason why this can't be done on a larger scale, like a park-wide scale or even a city-wide scale. And if this software were to be used as an operating system, it would allow for data to be tracked between users. You could have RPG elements where you create an avatar for yourself and you're constantly being tagged with different data, and your character can be customized. Other performers within an environment or experience can, be given your metadata and customized dialogue to you. And even virtual queuing, where you can dynamically add yourself to a queue and get a push notification when it's your turn to board. All of these things are very exciting, and we're only scratching the surface, but expect to see some of these things happening in the next few years as the line between location-based entertainment and video games continues to blur. In terms of what's next for Worldbuildr, we're currently operating as a services company, but we are developing our product as a SaaS model, where every stakeholder, every user, every vendor on a project would have a license and a seat, and use it for design and iteration and communication. And then they would use it for the actual construction process, using tools like Unity Reflect, and AR that's at scale on site and things like that. And finally, post-opening, it is going to be an operating system where there is continual playback of all of the things that you have pre-programmed in the software. So it actually transitions from being pre-visualization software to actually being the operating software itself after opening day. So a few big takeaways here. I think really the biggest one is that game engines like Unity are not just changing the product of experiences and the types of experiences that are out there, but they're also changing the process itself, the design and production process. And using tools like this, we're really able to iterate on the creative, we're able to mitigate risk, and we're able to verify ROI, which are some of the most important things that you need when you're developing an attraction or experience. Another big takeaway is that these new attractions will have interactivity and customization, and this is not just a fad. This is here to stay. This is what the audience expects these days. And then finally, this idea of a digital twin, and the fact that as you develop a simulation, with the goal being that it will ultimately operate a physical installation, what ends up happening is that you create this digital twin as a byproduct of the process itself. So on opening day of your location-based experience, you also now have a digital twin that you had to pay no additional money for. You didn't have to hire anybody else to do. But now you have a virtual world version of the physical site that you have just opened. And this becomes increasingly important, in a post-COVID world. COVID has really exposed the fact that a lot of these location-based experiences, like theme parks and museums, they have this Achilles heel where if the gates are closed, the per capita spending drops to zero. And now there's a way for these experiences to monetize their digital twin and continue to gain revenue from their visitors without them having to go to the physical site. And there are great opportunities there for connectivity. If you have somebody exploring a virtual digital twin of the physical site, perhaps unlocking some achievements or customizing their avatar, and then they go to the physical site, the transition of that data from your digital twin profile to the location-based show control operating system is more seamless than ever before. So it's a very exciting time. It's a very disruptive time, and Worldbuildr and Unity are at the forefront of this disruption, and we're very excited to see where things go in the coming months and years. So I want to thank you for your time and for your interest. I encourage you to check out our website at worldbuildr.com and follow us on social media at Worldbuildr. And thanks very much.